In this video, we're going to look at some other examples of the substitution method. So here we have integral x e to the x squared dx. You will notice immediately that x is half the derivative of the exponent. It is half the derivative of x squared because derivative of x squared is 2x. And this is our motivation for using the substitution rule. So we will let u be equal to x squared, the exponent. The derivative du dx will be 2x, so the differential du is 2x dx. Now let's divide by 2 and we get 1/2 du is equal to x dx. Let's put this in a box. Alright, so here we have integral e to the x squared times x dx. We will rewrite it in this way. It will make it easier to do our substitution. So e to the x squared, this is going to be equal to e to the u, and x dx is 1/2 du. Now we have an integral in terms of u, and it is going to be easier to integrate. So we have 1/2 integral e to the u du. 1/2 can pass through the integral, and integral of e to the u is just itself. That's 1/2 e to the u plus c. Now replace u by x squared, 1/2 e to the x squared plus c. It's very important that at the end you have your answer in terms of x, because the original integral, integral x e to the x squared dx, was in terms of x. So now we have the answer in terms of x. So the integral x e to the x squared dx is equal to 1/2 e to the x squared plus c. Alright, let's look at another example. Here we have integral x third root of 5 minus 4x squared dx. So we will let u be the inside function. U is equal to 5 minus 4x squared. The derivative is going to be, derivative of 5 is 0, and derivative of minus 4x squared, applying the power rule, will be minus 8x. So du, which is a differential u, is equal to minus 8x dx. Let's divide both sides by negative 8, and what we get is negative 1 over 8 du is equal to x dx. So let's rewrite the integral as third root of 5 minus 4x squared times x dx. Now we can replace third root of 5 minus x squared by third root of u, because u is equal to the inside function 5 minus 4x squared. X dx can be replaced by negative 1 over 8 times du. So now let's rewrite the integral in terms of u. So that's going to be third root of u times negative 1 over 8 du. Negative 1 over 8 is a constant. It passes through the integral. We get negative 1 over 8. And third root of u can be written as u to the 1/3. That will make it easier to apply the reverse of the power rule. And that gives us negative 1 over 8. And integral of u to the 1/3, add 1 to the exponent, so we get u to the 4/3. Divide by 4/3, that's equivalent to multiplying by 3 over 4. And plus c. So let's rewrite this as minus 3 over 32 u to the 4/3 plus c. Now it's important to get our answer back in terms of x because the integral was in terms of x. So substituting u back in, we're going to get 5 minus 4x squared to the power of 4/3 plus c. So the answer to the integral x third root of 5 minus 4x squared dx is equal to minus 3 over 32 times 5 minus 4x squared to the 4/3 plus c. Now if you were to differentiate this answer, you should get the integrand back. That might be a good exercise to do on your own. Alright, let's look at another example. Here we have integral x sine of x squared dx. So we will let u be equal to x squared. Its derivative du dx is 2x, so the differential du is equal to 2x dx. Now divide by 2 and we get 1/2 du is equal to x dx. Let's put this in a box. So we have integral sine of x squared multiplied by x dx. Now sine of x squared, that's just going to be sine of u, because u is equal to x squared. X dx can be replaced as 1/2 du. We now have the entire integral in terms of u. So let's rewrite that. That's going to be 1/2 sine u du. The 1/2 passes through the integral. We get 1/2 integral of sine u du. And integral of sine u is going to be cos u. That's negative 1/2 cosine u plus c. Now we have to get everything back in terms of x because the original integral was in terms of x. Negative 1/2 cos of x squared plus c. So the integral x sine of x squared dx, this integral computes to negative 1/2 cos of x squared plus c. And if you were to differentiate this answer, you will get the integrand back. That's a good exercise to do. All right, let's look at another example. Here we have integral t over third root of 1 minus 3t squared integrated with respect to t. We're going to let u be the inside function. So let u be equal to 1 minus 3t squared. Differential du will be equal to minus 6t dt. Divide by negative 6, we get negative 1 over 6 du is equal to t dt. Let's put this in a box. So what we have is integral 1 over third root of 1 minus 3t squared times t dt. Now we can replace this part of the integrand by 1 over third root of u. And t dt can be replaced as negative 1 over 6 du. So let's rewrite this. We have 1 over third root of u times negative 1 over 6 du. Now negative 1 over 6 is just a constant, so it passes through the integral. So what we get is negative 1 over 6 integral, and we can rewrite 1 over third root of u as u to negative 1/3, so we can reverse the power rule. That gives us negative 1 over 6. And add 1 to the exponent, we get negative 1/3 plus 3 over 3. That's going to be 2/3. Divide by 2/3, that's the same as multiplying by 3 over 2. And plus c. Now let's simplify a little bit. We get minus 3 over 12, that's minus 1/4, times u to the 2/3 plus c. And let's put u back in, get the answer in terms of x, because the original integral was in terms of x. Negative 1/4 times 1 minus 3t squared to the 2/3 plus c. This is the answer to this integral. All right, let's do a little bit of a review of the technique that we've been using. So in all the examples that we looked at, we were applying the substitution method. And here's the theory. Integral f of g of x times g prime of x dx. And in all the examples, we let u be the inside function. Let u be equal to g of x, du dx, the derivative of u with respect to x is equal to g prime of x. Multiply both sides by dx, and we'll get du is equal to g prime of x dx. So we have integral f of g of x times g prime of x dx. We replaced f of g of x by f of u, because u is equal to g of x. G prime of x dx, that is replaced by du. So now we have integral f of u du, and hopefully this will be an easier integral to solve. So once we anti-differentiate f of u, we get capital F of u plus c, where capital F of u is the antiderivative of f of u. And now put u back in, substitute back in to get your answer in terms of x, f of g of x plus c. And if you were to differentiate this answer, you will get the integrand back. In fact, we can do that. Let's differentiate d dx of f of g of x plus c. Derivative of capital F is going to be small f, keep the inside intact, f of g of x. Now differentiate the inside, differentiate g of x using the chain rule, that's g prime of x. And if you differentiate the constant c, that's just going to be 0. There it is. All right, thanks.